Hello everyone, our proposed project is wireless eye control device for the paralyzed. Inclusion of computers and automated machinery has made revolutionary changes in our day-to-day life. These kinds of changes benefit some groups in our society but unavoidably create new barriers to a disadvantaged minority such as people with physical disabilities who cannot access manually computers with dexterity as other people do. About 1 in 50 people have been diagnosed with some form of paralysis, transient or permanent. Some of the body parts of paralyzed persons will not function properly irrespective of the cause of the situation. Paralysis is a loss of muscle function for one or more muscles. Paralysis can be accomplished by a loss of feeling in the affected area if there is sensory damage. Paralyzed people find it difficult to move on without the help of caretakers to carry out their basic works. In this busy modern life, instead of wasting someone's valuable time for taking care for the paralyzed, the project proposes an assistive device which uses the wink of eye to control the device by receiving the light from the eye through optical sensor. The advantage of this device is that it will not give much strain to the paralyzed persons because it just involves winking of the eye. Now let us come to the block diagram. The IR pair are placed in front of both the eyes. The rays coming from the eyes fall on the IR pair. Depending on the opening and closing of the eyes, the IR output changes. The output of the sensor is given to the pins of the Arduino transmitter. The status of the eye are passed to the receiver wirelessly through XB. The receiver and PC are connected with each other through USB cable. The MATLAB virtual mouse program takes commands from the transmitter and the mouse pointer moves accordingly.
Components used in sensor circuit are IR LED, photodiode, LM358M, 2 150 ohm resistance, 1 10 kilo ohm resistance, 1 10 kilo ohm variable resistance. IR LED. An IR LED is a type of LED which emits light in the frequency range of infrared, hence the name IR LED. Photodiode. A photodiode is a type of diode which detects light. We can think of it as having a very high resistance when no light is falling on it. As we increase the intensity of light incident on it, the current through it gradually increases too. So, when we open our eyes, the rays from the eye make less resistance value for photodiode. When we close our eyes, rays from the eyes make more resistance value for photodiode. LM358M. LM358M is a general purpose dual operational amplifier. Basically, we use it to compare two voltages. One is fixed and other is chosen to be reference value. If the parameter controlled voltage is higher than the reference voltage, then the IC should give high output, and if it is lower than the reference voltage, then it should give low output. So we see that the IC gives only two types of outputs, which we designed to be 5 volts and 0 volts. This makes our sensor digital. When power supply is given, IR LED emits light that is reflected from eye and will fall on the photodiode. The photodiode's resistance come down to a finite value. The drop across the 10 kilo series resistor is what we use as an input, which is compared with the threshold. The point to be noted here is that more the incident rays on the photodiode, less will be the drop across it, and hence more will be the drop across the resistor. If the voltage developed across the resistor is greater than the threshold set by us, the output of the IC will be high, else it will be low. Hence, if our reflected radiations is never strong enough to be greater than the threshold, then we have a constant low as output. If we close our eyes, we get one voltage level, and when we open our eyes, we get another voltage level. A threshold value is chosen to be between these two voltage levels so that when we close and open our eyes, only high and low outputs we get from the comparator. The threshold value will be different from person to person.
In our project, we are using Arduino FIO-based Zigbee development platform NVIS35D. It is based on Atmega 328P AVR microcontroller. It provides a platform on which design and implementation of extensive embedded system-based design can be performed. Its features are Atmega 328P MCU clocked at 8 MHz, USB bootloader to program Atmega 328P device, wireless communication via XB series, master reset key for hardware reset, Supply from USB or external supply or battery. LED indication for various operation. The Arduino FIO is intended for wireless applications. The user can upload sketches, that is program, with a USB cable or by using a modified USB to XB adapter, or the user can upload program through wireless using XB. Arduino is a popular open source single board microcontroller. The hardware consists of an Atmel AVR processor and onboard output support. The software consists of a standard programming language compiler and the bootloader that runs on the board. The Arduino IDE is a cross-platform application written in Java. Arduino programs are written in C or C++. The microcontroller which we are using is Atmega 328P. The Atmega 328P is a low-power CMOS 8-bit microcontroller based on the AVR enhanced RISC architecture. For wireless communication, we use XB series. The XB modules can be loaded with various firmwares to support Zigbee. The XB radios are based on the 802.15.4 standard designed for point-to-point and star communications at over-the-air baud rates of 250 kbps. The XBs can operate either in a transparent data mode or in a packet-based application programming interface, that is API mode. The mode which we are using is API mode. XCTU is used to configure XB series. To set baud rate and comport number, we use XCTU software. To convert the I-wings into the mouse movement, we use MATLAB software. MATLAB is a multi-paradigm numerical computing environment and fourth generation programming language. It allows implementation of algorithms, creation of user interfaces, and interfacing with programs written in other languages, including C, C++, Java, etc. The version of MATLAB which we are using is 7.5 and its release name is R2007B. This is the whole setup of the wireless eye control device for Paralysed. Here, both the sensors are placed in front of both the eyes. The output from the sensors is given to the comparators, which are right and left comparators, which are placed on the top of the head. The red LED indicates right comparator and the green LED indicates the left comparator. The output from the sensors is given to the Arduino board. This is the Arduino board. The output from the right sensor is given to the 8th pin of the Arduino. The output from the left sensor is given to the 7th pin of the Arduino. The power supply to the sensors is taken from the Arduino board, where the 15th pin indicates the positive of the power supply and the 16th pin indicates the negative of the power supply. The power supply to the Arduino will be given using a A to B USB cable, where the other end of the USB cable will be connected to a laptop or PC. Or the power supply to the Arduino can be given using a battery by connecting it to the J10th pin of the Arduino. Now we are going to see how the I-wings moves the mouse pointer. We are going to run the MATLAB program. Close your right eye. We can see that the mouse pointer moves to the right. Close your left eye. We can see that the mouse pointer moves to the left. Close your right eye. We can see the click operation when both the eyes are closed. Close both the eyes. The folder gets opened when both the eyes are closed. Close your right eye. The mouse moves to the right. Close your left eye. The mouse moves to the left. Now we can see the up-down movement of the cursor. Close your right eye. When the right eye is closed, the cursor moves down. Close your left eye. When the left eye is closed, we can see that the cursor moves up.
We hereby thank Texas Instrument for giving us this opportunity. We thank our mentor, Mr. V. Vikas, Assistant Professor, for his precious time in guiding us throughout the project. We thank our HOD, Mr. K. Ramalinga Reddy of the ETM Department, for his encouragement in making our project successful. We thank the supporting staff for helping us in making the video. We thank the director and the management of G. Narayanamma Institute of Technology and Science for the support.